Hey everyone, today we're diving into an essential topic in chemistry, balancing chemical equations. By the end of this video, you'll not only understand how to balance equations, but you'll also know why it's so important and get some great tips for making it easier. So, let's get started. Before we dive into how to balance chemical equations, let's talk about why we need to do it in the first place. In chemistry, a balanced equation represents a chemical reaction where the number of atoms for each element is the same on both sides of the equation. This means that mass and matter are conserved, which brings us to the first important concept, the law of conservation of mass. This law states that matter cannot be created or destroyed in a chemical reaction, which means that the total mass of reactants must equal the total mass of the products. So, to make sure we're not violating this fundamental law, we need to balance chemical equations. When balancing an equation, you'll come across two important terms, coefficients and subscripts. Let's discuss the coefficients. These are the numbers placed before the chemical formulas to indicate how many molecules or moles of a substance are involved in the reaction. For example, let's see the equation. The 2 in front of H2 and H2O are coefficients. Subscripts are the small numbers found within a chemical formula that tell us how many atoms of a particular element are in a molecule. In H2O, the number 2 is a subscript that tells us there are 2 hydrogen atoms in each water molecule. Alright, let's discuss the method for balancing chemical equations. We mainly focus on the hit and trial method, also known as the inspection method. This method involves adjusting the coefficients to balance the equation by trial and error. Let's take a simple example. Here on the left we have 2 hydrogen atoms and 2 oxygen atoms, but on the right we have 2 hydrogens and only 1 oxygen. So this equation is not balanced. We need to make sure we have the same number of hydrogen and oxygen atoms on both sides of the equation. Now, how do we balance the chemical equation? Let's apply the hit and trial method. If we place a coefficient of 2 in front of H2O and check the equation, the oxygen atoms on both sides of the equation are equal, that is 2, but hydrogen atoms are now unbalanced. We have 4 hydrogens on the right and 2 on the left, so to balance the hydrogen, we put another coefficient of 2 in front of H2 on the left, and now you see, hydrogen and oxygen atoms are equal on both sides. Because we have 4 hydrogen atoms on the left and 4 hydrogen atoms on the right, similarly, we have 2 oxygen atoms on the left and 2 oxygen atoms on the right. This equation is now balanced. Let's try one more but a more complex reaction this time. Here we have 1 aluminum atom on the left but 2 on the right. Also, we have 2 oxygen atoms on the left and 3 on the right. So this equation is not balanced. To balance this equation by using the hit and trail method, we place a coefficient of 2 before the aluminum on the left side. Now, if we check the oxygens, we have 2 oxygen atoms on the left and 3 oxygen atoms on the right. This isn't balanced, so we adjust the coefficients on both sides to get the same number of oxygen atoms. If we add a coefficient of 3 on the left side and 2 on the right side, we get 6 oxygen atoms on both sides, which is now balanced. The problem arises with aluminum now. On the right side, 4 atoms of aluminum are present, but on the left, 2 atoms of aluminum are present. So we have to adjust the left side aluminum with coefficient 4, and now both aluminum atoms are balanced, as we have 4 aluminum atoms on the left and 4 on the right side. Similarly, we have 6 oxygen atoms on the left and 6 on the right. So this equation is balanced. Now, it's time for you to practice. Try balancing these equations using hit and trial method and see how quickly you can solve them. Give them a go and comment below with your answers. Before we wrap up, here's a little trick to help you balance chemical equations faster. It's called the Chomp Rule. This rule is composed of simple steps. Start by balancing carbon atoms first. Next, balance the hydrogen atoms. Then, balance the oxygen atoms. Balance the metal atoms. If polyatomic ions are present, treat them as a unit and balance them last. Let's take this equation as an example to see how effective the Chomp Rule is. In this reaction, we see carbon has 3 atoms on the left side and 1 on the right side. So add a coefficient of 3 to carbon dioxide to balance the carbon atoms. Now let's balance the hydrogen atoms. We see 8 atoms on the left side and 2 atoms on the right side. If we add a coefficient of 4 to water, Now hydrogen atoms are balanced. Now lastly, balance the oxygen atoms. We see 2 atoms on the left side and 10 atoms of oxygen on the right side of the equations. If we add a coefficient of 5 to oxygen on the left, then oxygen atoms are now balanced. We see the final balanced equation now. There are no metal and polyatomic ions in this reaction. So we skip those steps. This trick can save you a lot of time, especially with more complex equations. And that's it for today's video. I hope you found this method useful and now feel more confident when it comes to balancing chemical equations. Don't forget to like, share and subscribe for more videos. See you in the next one.